Hello class, today we're going to start talking about chapter 4, which is looking at linear functions and relations. This first video is going to focus on section 4.1, which is graphing in slope-intercept form. By the end of today's lesson, you will be able to write and graph equations in slope-intercept form and use this idea to model real-world situations. Slope-intercept form is another way that we can write a linear equation. In chapter 3, we looked at standard form. In chapter 4, we're going to look at slope-intercept form and point-slope form as well. In slope-intercept form, we have y equals mx plus b. If you remember from chapter 3, m is the variable that we use to stand for slope. In this case, our b in the back is going to be our y-intercept. That is where the graph crosses the y-axis, which is that vertical axis. The original form of the equation is written y equals mx plus b. That is when b is a positive value. You may also see y equals mx minus b. That is when b is a negative intercept or below the x-axis. When you are graphing a slope-intercept equation, the first thing you're going to do is graph 0, b. So whatever that y-intercept point is, you're going to put that on the vertical line. If necessary, you're going to turn the slope into a fraction. Sometimes it'll already be a fraction. Sometimes you're going to have to do that by putting 1 underneath the number. Then you're going to use the slope to graph the point. Remember, when we are looking at our slope and we have a number, so we'll say 2 over 3, that means 2 up and 3 to the right. If your top number is positive, that means up. Negative would mean down. On the bottom, positive number means right, and a negative number means going to the left. Then you're going to connect the points using a straight edge and making sure it is going all the way across the graph with arrows on both ends. So, for example, we got write an equation in slope-intercept form for a line with a slope of 4/5 and a y-intercept of -2. Then it wants you to graph the equation. So what we're going to do is we're going to pick out our slope and our y-intercept. So we've got y is equal to a slope of 4/5 replacing m. The x stays there, and then our y-intercept is negative, so it's -2. When I come to put this on the graph, I'm going to start with 0, -2. That's my y-intercept. Then I'm going to use my slope right here, and that is telling me that I am going 4 up, so 1, 2, 3, 4 up, and 1, 2, 3, 4, 5 over to get my second point. Obviously, you don't need these middle dots in there. I was just using it as a visual to help you see what is happening. Then you need to go ahead and connect those points using your straight edge, making sure that it is going all the way through the entirety of the graph, and finally putting those arrows onto the end to show that the line continues on forever. Go ahead and try and write this equation and then graph it on your own. So you should have got an equation of y is equal to -3x plus 4. That starting point then is at 0, 4, so 4 above the axis. And then we are using that slope to go down 3 and right 1. Remember, there's only one negative there, so that is a -3 and a +1 that you're moving to the right. The next thing we're going to talk about is rewriting an equation so that it is easier for us to graph. Right now we have the equation 3x minus 4y is equal to 12. That's written in standard form. To make it easier for us to graph, we're going to turn it into y equals mx plus b. So we start with our equation of 3x minus 4 is equal to 12. Our goal is to get the y isolated on its own side, so we're going to subtract 3x, giving us -4y is equal to -3x plus 12. You could have written 12 minus 3x. Either way will work out the same. And then we need to get rid of that -4 in front of the y, so we're going to divide by -4. We do that on all pieces of the equation. So if I divide the first part by -4, I have to do it to the other two pieces as well, giving me a final equation of y is equal to, two negatives make a positive 3/4 x minus 3. Positive divided by a negative is a negative. Notice how I left 3/4 as a fraction. You do not want to turn that into a decimal because you always want your slope to be a fraction. Going on to my graph, I am going to start at the point 0, -3. And then I have my slope, which tells me to go up 3 and over 4 to get my second point. Once again, you're going to want to connect those using a straight edge. So we've got our line going through all of our points and finishing up by putting the arrows on the end. Go ahead and try this one on your own, rewriting into slope-intercept form and then graphing. Once you rewrite, you should have gotten an equation of y is equal to 2/5 x plus 2. So our graph starts at 0, 2. We go up 2 and right 5, and then draw that straight line in across. Now we're going to talk about what happens if we only have one of our two variables. So for example, we have the equation y is equal to, 2y is equal to -4. Again, we need to make sure that y gets by itself in order for us to graph. So in order to get rid of the number in front of the y, we're going to divide by 2, and I end up with y is equal to -2. We have no slope here, so we're going to start with that y is equal to -2 point. What this is telling us now is that y is constantly equal to -2. So that first point I graphed was at 0, -2. Another point that I could graph is at 4, -2. Another point would be at 8, -2. So when I have just y by itself, it is going to give me a straight line going horizontally across the graph. The other situation that you could run into is if you have something where you just have the variable x. So we'll say 3x is equal to 6 to start. Again, you're going to want to solve that to get the variable by itself. In this case, there is no way for us to set it equal to y. So we're going to get it set equal to x. We don't have a y-intercept, but it does tell us that x is equal to 2. Similar to what we had in the y case, we are looking for all points where x is equal to 2. So that first one I graphed was 2, 0. Then I'm going to put on 2, 10, or 2, -4. So we're looking for all of the possible places that x could equal 2. When I draw in that line, it's going to give me a straight vertical line instead of a straight horizontal line. So you need to be able to identify if you have a y equals part, you are going to get a horizontal line. If you have an x equals equation, you are going to get a vertical line at that point. If you have questions about that, please let me know when you get to class. Last thing we're looking at is being able to take a situation and turn it into an equation in order to help us graph. Derek is buying a new stereo system on a layaway plan. His initial payment was $75, and he pays $10 each week after. Write an equation to show the cost C after W weeks. Then graph the equation and find the cost after 8 weeks. So instead of using X and Y, they are giving us C and W. Since C is what we are solving for, that would take the place of our Y, and W is what we're putting in, so that would take the place of our X. So when we are looking at this, we want the cost is equal to, now we have 75 and 10. When you are looking to decide which one is the slope of the equation, there are two key words that you could look for, one of them being each, the other one would be per. That's going to tell you that that is continuing to increase as you go, so that is going to be your slope value. So we're going to say C is equal to 10W, $10 per week, plus the $75 he started with. Now, when we go to put this on the graph, right now we're at a 10 by 10 graph in each quadrant, so we're going to need to renumber. Since we have the number 75, which is kind of bigger, I'm going to go up by tens. So we went up the side by tens. We don't need to renumber the x because we are just counting week by week. So we're going to go ahead and start with our initial point on the y-axis of 0, 75, which puts us right there. And then we are going up. We're turning our slope into a fraction. We're going up 10 over 1. Now that doesn't mean we're counting 10 spaces up. Remember, because we renumbered the side of our graph, we're going up by tens. So we go up 10 and over 1 to give us that new point. Because you can't go negative in time, we do not need to draw our line into the negatives. We can't have -1 weeks. We can't go backwards. So that's what our graph would look like. Then it's asking us to solve to find the cost after 8 weeks. So we're going to use our equation and plug in for W10. So, or excuse me, 8. So we got 10 times 8 with 10 times 8 plus $75. So our cost is equal to $80 plus 75, giving us a grand total of $155. If you have questions about this or any other part of the lesson, please let me know when you get to class.